All right, we meet again, and today we're going to look at perimeter and area of parallelograms. Now, before we get started, let's just remember what a parallelogram is. A parallelogram is a four-sided shape, but what makes it unique is that it has to have two pairs of parallel sides. So really, the only quadrilateral that's not going to fit the bill of a parallelogram is a trapezoid. So everything else is going to be fair game. So things like squares, rectangles, a rhombus, which is sort of like a pushed over square, and then a category that really we only call it a parallelogram. Oops, and I made a mistake, so I'm going to erase a little bit over here. But a parallelogram, if it's sort of, think of like a pushed over rectangle, it doesn't really have a special name, so we just call it parallelogram. But beware that a rectangle, square, and a rhombus are all parallelograms as well. Now we already have a formula and method for finding area of both squares and rectangles. What you're going to find is that these other parallelograms are going to be very similar to that. There's just something that makes it a little bit trickier. Let's take this parallelogram as an example. Like I said, this one is not a rectangle, it's not a square, it could be a rhombus, but I have a feeling it's going to be a parallelogram. Now, there's two things we're going to pull up again, just like we have with other ones, is we're going to look at both perimeter and area. Again, we know that perimeter is distance around, so if I were to walk around the outside of this parallelogram and find out the distance, the total distance, that would give me my perimeter. And normally, if I wanted, I could just count. And part of this would be easy. If I was starting here, I could go 1, 2, 3, 4, and I know the bottom is 5, 6, 7, 8. So I have a total of 8, but the problem is when I go on the sides, because they're slanted, I don't really know. I mean, you might want to assume that they're each 4 as well, but we don't really know that. So that gets tricky. The other part that gets tricky is when we get to area, because again, we could count the squares inside. Again, we could say 1 square, 2 squares, 3 squares, 4 squares, 5, 6, 7, and 8. But you're going to notice that what we're left with now are partial squares. And again, we could probably get a pretty good estimate. I might say that these together make another one, 9. And maybe these two together make another one, 10, which lets me believe that probably this is an 11 and this is a 12. So my estimate is that the area is 12 square units. But again, I'm not really sure. And my perimeter, my estimate is that maybe it's 16, but I don't really know. And so we have to investigate this further. Now, you've already had the chance to investigate parallelograms in class. And what some of you started to notice is if you could take off sort of a corner of the parallelogram, which is going to be a triangle, and in this case I'm just taking it off of the end there. If I could take that off, physically take it off, and move it over here, I would get a perfect rectangle that would look like this. Now, of course, it wouldn't be this size, but it would fit on there. It'd be like taking this part off, I'm going to blacken it out, and just extending this here. And now if I did that, I would have a 1, 2, 3, 4 by a 1, 2, 3. Now remember, I was estimating that those sides were maybe 4, and now I'm finding out that they're 3. So now I could actually find out that the perimeter would be the same thing as doing 2 times the length plus 2 times the width. So in this case, it would be 2 times 4 plus 2 times 3, giving me 8 plus 6, or 14. Now remember, my estimate was 16, so I'm close, but I'm not exact. And then the area, now that it's a rectangle, couldn't I just use my formula, A equals LW, giving me a 4 by 3, which is 12. And remember, I did estimate it was 12, and I actually ended up being correct. So this leads us to the new formula that we're going to use for parallelograms. To figure out the new formula, I'm going to look at another parallelogram on a grid. Again, I'm still thinking of this idea of, ooh, if I could take this off and make this a nice, perfect straight line and move it over here, what I would end up with is a rectangle that looks like this. And actually, I'm going to outline it in green now. Okay? Now, once I have that, I could totally just go ahead and count. I see 1, 2, 3, 4, 5, and I have 1, 2, 3, 4, 5, 6 rows, so that would give me a 5 by 6, which is an area of 20. So you might be thinking, well, I could just use the exact same formula. You absolutely can. The problem is that with parallelograms, instead of saying A equals LW, we often say BH. Because B is going to be the height, or excuse me, B is going to be the base, which is this, and then the H is going to be the height. Now I'm going to get rid of all of what I had before so you can see what I'm talking about. Because if you notice, this is the base, and even when I relocate that piece of the parallelogram over to the other side, the base never changes. The other thing that never changes is the height. It's always going to be this height. Even when I relocate. So again, we can think LW, and usually when I think parallelograms, I think squares, rectangles, rhombus, and parallelograms. So I kind of just think that they have the same formula, but I just remind myself that typically we call a parallelogram having a base, and we say it has a height because of the fact that it has slants on the side. And remember, height just means I'm standing at the very tippy top, and I drop something down, I don't roll it down the slope. Okay, so now if I do it, I say A equals, the base in this case is 1, 2, 3, 4, 5. The height is 1, 2, 3, 4, 5, 6. And oops, I realized I made a mistake over here and I said 20, and that really was 30, and I get 30 this way as well. Again, it's still going to be, in this case, units squared. It's square units. I just don't know if they're centimeters, inches, or what, so I just call them units in general. So this is a pretty brief video. I'm just reminding you that it's very similar to finding rectangles and squares. It's just your letters are going to be different when you talk about the formula, and it gets tricky when you're trying to count on a grid. So keep that in mind as you continue to work with parallelograms.